Alright, howdy folks, and welcome to Alwa's NES Awakening. This is stream number 17. My name is Paul. I go by InfiniteNesLives online, and we are porting Alwa's Awakening to the NES. If you're watching this on YouTube after the fact, there's links in the description to the recap at the end or anything else that was somewhat interesting. Just update on where we were from last time. We can jump over to CRT here. So we've had sideways, room, updates, and auto scrolling into the next room working. We got down working with attribute tables. Took quite a bit of effort, and we got it going. We still haven't gotten up working. And we concluded the stream with a bunch of reasons as to why that was being a major pain. Where did my... I had a browser tab open. Apparently not. Wait, what's right there? Oh. What is going on? I got too many desktops. Can't see them all. Okay. So this is a major pain because of our alignment. Not what I want. Upward scrolls, we start writing here, and we hit that boundary. And not only is that boundary a pain for all the special cases, but it's even a bigger pain because the last row of attribute tables, only one nibble is used because it's not 32 by 32, it's 32 by 30. So half of a nibble is unused. And that, gosh, things all set up wrong here. Yeah, so that is a pain because of, it's an extra pain because of that. I had some code. We got, where are we here? Okay, so the name table rows, here we have an attribute right segment, here's the read. So for my up scroll, I had 3 different special cases for read. Why does this not look familiar? So these are the name table rows. Load name table row. getting here? Okay, so add. So if it's so scrolling up. This. I feel like this is not the code that I was writing at the end of last stream. Up scroll, add a read. Here we go. This is where things get messy. So the initial plan was this name table 1 is always our default playfield. When we want to start up scrolling, we're going to start filling in these tiles here, and then that'll wrap around back to the bottom. In the first 4 rows, the first two segment of updates are relatively simple. But the third one has to happen at the bottom, and the bottom row is only half a name table or an attribute table byte. It's only 1 nibble per. It's half of the 8 bytes, a nibble of each byte, and then it gets more confusing. I did set it up right for the reads. Segment 0 and 1, then 2, and our mask has to flip around. And I have a special check for is it segment 0, 1, 2, or 3 a plus. And I have all that code. But the right segment gets even worse. And honestly, all of this feels like a mess. And I have a better idea. So dealing with this wraparound is a pain. But we can get rid of it. Instead of starting in the default position, the plan would scroll up. The top of the screen when we're done scrolling would be like here-ish, because we'd be off by a heads-up display worth. So this would be the top left corner. To get out of that position, well, really it'd be like here because of mirroring. To get out of this position, we have to draw the entire screen on name table 0, jump over there. With this being the top left corner. And then we could draw everything over again on name table 1, but 4 rows up to here, and we could jump back again. Then we'd be ready to scroll over. Well, if we do it the opposite. If we start off, before we do it, we get to the top of the screen, okay, it's time to scroll. First, load the current screen in name table 0. Draw it all in there. Same thing that's already in there, but draw it over here. Then draw the same exact screen that we're seeing again for where this is the top left corner. So now, as we scroll up, we're drawing everything in the new screen in the final location. So then we're done. So basically preemptively set things up so that they're nice and easy. And once the upward scroll is done, it's over with. It's the same amount of data writing. It's just writing the current screen 2 times to before scrolling as compared to scrolling into the new screen and then drawing the new screen 2 times, because we have that jog that we have to make. That way we're prepared for a horizontal scroll or a vertical, and we're in our default position. So to do that, the easiest way, cleanest way I can really think of is to start using functions. And I've wanted this for a while, but now I have a better idea of what I want these functions to look like. So if we think back to horizontal scrolls, we are just loading up a name table, or I'm sorry, a screen, a room in name table 0 from here down to here, and then we scroll into it. Well, let's just make that a function. So we're just gonna we're gonna start to refactor some of our code to where we can provide, we want a function that we just provide the pointer of the room data and the address of the PPU to start drawing it in. And that'll make everything easier. And then we can use that to we can call that function and provide the current room for here, then call it again, same function, same data, but for here, and then we can do an upward scroll. So let's leave our upward scrolling code for now and go all the way back. I guess I committed everything. Yeah, I wrote the read code, but it's untested. All right. So problem with this function is we're not just calling it once and it's returning and it's done. We basically need to call it every frame to perform whatever logic it is we're doing right now in and then I guess maybe have it call us when it's done. How do we want it? So I think this whole stream is going to be moving code around. But it's for the best. Oh. Okay. This right playfield. It's an old one we had. I think we don't want this function. We just want this function to load up name table data. We don't want it to do any scrolling. We will have a different function do scrolling, or we'll do it within the main, however. So and I guess to some degree, instead of breaking the current code in the process, we could create this new function. We can kind of ignore the issue that we have with the up scrolling not being complete because we don't have the tools that we want to do it yet. We can think about horizontal scrolling and have it basically handle the scroll done part where we go back to default. So if we work on a function right now that does that, that'll get us towards our path. I feel like the current code is so massive. I can go ahead and put it in a function, but it's not a good function. It's just moving code. I'm not calling it different stuff because okay, so we load scroll dir. If it's done, we skip it all. Horizontal, if it's not horizontal, so camera move. If the camera bit's not set, we jump to horizontal camera done. Where are we actually loading up the... Yeah, so I have that code early for whatever reason. I guess that's how my branch is. So here's the updates. So if the scroll bit's set, then we're loading in our data. So to some degree, this is, I think, or we can start it. So we scroll count. $16 frames for full play field. They're not all 56. So there's 16 frames, full play field. Updating the pointer, fast horizontal updates. Then we have a last. And then we update the attribute tables. Load data. We decrement scroll count. If we're done, clear scroll dir so we stop updates. I think no scroll is basically just we're done. So we decrement the frame number if it's not equal, we keep going. So to some degree, we can have this be and maybe the function returns scroll count. Do we use scroll count outside of this? I don't think we do for the so here we're done with the horizontal updates, and so we set the okay. All right, so let's try that. It's expecting scroll count to be 0 on it. So we'll call this no, it doesn't have any arguments right now. So this function's basically going to return so the accumulator equals scroll count. So I don't really want to use rely on the flags though, do we? I mean, it'd be nice to can we just rely? Can we have the 0 flag as a return, so then we can say if it's done or not? Just have to make sure it's preserved, and I'm pretty sure it is, because that'd be easier than saying, oh, a equals 0 and then comparing it and putting it in there and comparing it when we could just say it's in the Z flag. All right. I've never done anything like this though. So yeah, so the flags aren't affected from JSR. So why not do that? Because the deck will set the Z flag, and then when we're coming out of it, we can one thing I like to do sometimes is so if we define it as that, then we just move that code and so make sure I'm loading the right file here. Okay, yeah, 1008. All right, so it's pretty cheap. We just moved that code, but let's start adding in some arguments. So this is setting its own pointer based on scrolldir, which is not how we want it to work. We want to provide this function with the pointer or maybe set up the nat pointer before calling. Yeah. We want to set it up before calling. We don't want to provide it as an argument because that's going to be, this function is going to be updating it as we go. So when we call it, if it's already set up, how's it gonna? Okay. That's how it knows its first call is scroll count is 0. So this function will copy data from the pointer into the update buffer and set the proper values to nametable update length to trigger the correct updates. Now, it assumes that the update is we should be able to change which name table fairly easily, but it's assuming that we're starting here. By the time we get to the end of the screen, it's going to draw it in the attribute tables. The attribute tables will immediately follow. Which works well, mostly. We'll draw the other. So maybe we need to tell it which. Where are we loading in the address? Increment the first 2 bytes of the buffer, which is written as PPU address. So we're incrementing by 56. And on the first we're assuming it's already set. Oh, that's incrementing the file pointer, the name attribute table pointer. What about name table update? Where am I initializing that? Oh, name table set nat pointer's doing that. Yeah. This function's kind of a hack that does it all based on direction, and it's not going to really know those things. Well, we can tell it direction, but it's assuming so if it's left, it's setting the nat pointer and then jump to horizontal scroll, which horizontal scroll is storing the initial PPU address, which we don't really want that to do because we want to be able to call this function instead, which, so we can make that a prerequisite. Row 4. Now we can set it to whichever name table we want, but the way the data is structured, it's got to be, it's assuming the attribute tables follow. So let's set it there. In reality, okay. So it's no longer doing that. I have a hard time. I should just hack the code and be done with it, but Yep, that didn't work. Oh, because it calls it every single time. I'm updating it to that one every time. So we can't just call it beforehand. We want it to be set before we call, but we so in our calling code, oh, not so much. Let's try. This isn't where I want it, but make sure that I'm not. There's something else going on. Why isn't that? Oh, we're calling set nat pointer every time. That's why. I thought I tested that. Okay. Yeah, so in the calling code, we still need to know if this is the first time, because we have to initialize. Doing that with scroll count. Also using that to say it's the last time, but then we shouldn't be calling this code again. I need something else. I mean, I'm checking on entry and exit, which are two different locations. On entry, if it's 0, then it's init. If on exit, if it's 0, it's end. But I don't like it. Okay, so get rid of all this. I'm talking about vertical scroll switch. So this function, you need to have the NAT pointer set on call and the PPU address set on call. And that can only be here or here. Now we can maybe add some arguments that will help us support other means. But for now, if we get this right, we should be able to. So we're calling it the first time to draw the play field here, scroll left into it. Then we'll call it again to redraw it back in name table 1, and we'll flip the name table bit in the PPU to go back to the default. We're still handling the scrolling. Part of me says move this scrolling code also. So this will it's going to use scroll direction to scroll left to right 4 pixels at a time. So instead of this, so because what I was doing before was I was loading X. If it was not equal, I was returning. I was going to the end of it. If it is equal, we're done, and then I'm flipping the bit. Oh, this logic I don't really want in here. If scroll X is 0 on exit, we know we're done. So we should be able to just return here. Okay. Hey, Robert, how we doing? Well, we're doing okay. Things are getting complicated on upward scrolls, and they don't work. You can see here. The data gets updated. The tiles get updated, but not the color. Because attribute tables are a pain, and I'm realizing that if I could reuse some of my code, it would make life easier. I could simplify the task of scrolling up, so I finally have a motive to moving all my blob of main code into functions that I can reuse and simplify, make it life easier. So let's see. Oh, yeah, I try. For comments, I mean, I know that I have no idea what I'm doing, and so if I don't, there's lots of benefits to commenting your code. Writing out what you want to do, basically pseudocode. Telling yourself when you come back and looking at the code, if you don't have comments, you can't easily come back to code and debug it. Like, this is what I say I'm doing. You're like reading the code, trying to figure out what's going on, but you don't know what your intent was, and especially with assembly. But I err on the side of too much comments. The drawback is I rarely update my comments well, or I'm not good about updating my comments, so lots of times my comments will be wrong. But that doesn't cause bugs. Your code being wrong does. So I don't know. I seem to get by. It's always a struggle. Yeah. Yeah. You don't always trust the comments, but sometimes when you don't know what's going on, and the comments can help you figure it out. But okay, so here we know we're done scrolling the camera, and I set the go to default bit, and I store and scroll dir. And then we're not doing anything about it after that point. Here so horizontal camera's done. I say horizontal name, add or updates. Check if we're scrolling. Okay. Yeah, this code is a little bit backwards because we moved the camera. We update and then we move the camera. Can we move this code so it's not so confusing? I have, because I'm loading scroll dir, I'm ending the camera bit, jumping to camera done. Loading scroll dir, ending the scroll bit, jumping to no scroll if done. So let's yank that code. So load scroll dir. If the scroll bit is set, if it's set, we'll do this. If it's not set, we want to do check cam. Okay. Check horizontal camera. And if it's not set, if camera is not set, we'll go to horizontal camera done. And this is code that we just moved. But here's where I'm setting the camera. Oh, that's the only problem is if I do it the other order, well, I can just skip past it. And did I move this code? I don't think I did. Yeah, and I do jump to no scroll. I'd skip over the horizontal camera done. So that should be okay. I skip over the horizontal camera check. So if I do that, then I should be able to comment all this out. Nothing should change. Okay. Good. Okay, this is looking better now. But this horizontal cam done, I don't. Why? If that's done, I think we can just, because all of this is vertical scrolling code, which is not going to be happening. So we can just jump to no scroll. And really, I should call no scroll end scroll. .342 and 442. Yeah, these are. Wait, what? 342, 352. Yes, change those to jumps. Okay. This is cleaning up. So on entry, check scroll dir. If it's set to nothing, we're gonna end scrolling. If it's horizontal, well, if it's not horizontal, then we're gonna check for scrolling vertical. Otherwise, we're in horizontal scroll. So first we check the scroll bit. If the scrolling bit's not set, and really that's kind of like an update bit, we'll check to see if it's time to move the camera. Otherwise, we're going to this is our first frame, so we'll update. We'll initialize our PPU address and our pointer, and we'll call our draw function that we created. If that function returns with a 0 flag clear, then first step is we draw the next room in this name table. We scroll. Once that's done, we're going to move the camera. We scroll into it. Once that's done, we are at, okay, so we set the camera bit after, once the update's done, we set the camera bit, the camera moves in. And when the camera bit is set, here we're checking for the camera bit, we're gonna call our move the horizontal camera. On first call, scroll X equals 0. And on entry, it equals 0 on the first call, and on exit, it equals 0 on the last. Let's make note of that. It's not the greatest, but it just works. Which just makes sense because name table bit, it's an 8, scroll X is an 8-bit value, which is somewhere in here, and the PPU sets the name table bit for which one is being visible. So once we've scrolled into it, if it's 0, we're gonna set the go to default bit mask, store it, and we're going to so now we are going to we've done our whole horizontal scroll. We're displaying in name table 0, but we're not ready for the, if we move rooms again, we're not in our default position. We got to get back here. If this is not, so this is going to be check go to default. If it's not, if the camera bit's not set, then we're going to go to check go to default. So we will load scrolldir and go default bit. And if that's set, jump if equal. If it's clear, we're going to end scroll. So scrolling is done, but we're out of default nametable 1. So the first thing draw current playfield in nametable 1, which is the same thing we did back here. But we need to change. So I'm not sure of a couple things. One thing we want to be nametable 1. So we're going to change this address to, what is it, 24. So that should be fine, but I'm not sure if set nat pointer is right now. It's using the scroll direction, which should still be right. We haven't cleared the scroll direction bit. It's not how we need lookup tables and stuff, not just based on direction. Okay. So let's assume that's working. If so, it's when it's done. Drawing, the Z flag will be clear, just like before. So it's going to be similar to this code. Let's paste this for now. So we'll go to end scroll if it's not clear. If it is, then now it's time to jump back to nametable 1. To do that, it's relatively easy. It's just name table oh gosh, what is it? Oh, scroll name table. Select 0 through 3. Why don't we just set it to 20, 24, 28, or 2C? Oh, because that's what actually gets written to... Yeah, PPU control. PPU control, you write 0, 1, 2, or 3. But that'll... So we'll update that here, and that won't actually get updated until vblank. But could we just write it here? I don't know, but we have a variable, so let's use it. So 1. So that's all that needs to happen. But we want to clear our go to default mask, and I guess everything should be done. And so we can clear we should be able to just load 0, or I guess it's no scroll. Where's scroll none? Think it works. Seems simple enough. Skip init PPU adder. Oh. Yeah. I don't like it. But sometimes it makes sense to use non-NES labels. Well, that was interesting. What happened there? It loaded a different room. I think it loaded the, yeah, it loaded room 1 for some reason. I mean, it worked, but it loaded the wrong data. Why did it do that? Set, which room is that it loaded? that room 3? Yeah, okay, I think I know why. It loaded room 3, which is supposed to be, so I did, which is supposed to be right. Yeah. So set nat pointer didn't work. So it's comparing to scroll. It's loading scroll dir and it's comparing to scroll up, but it doesn't actually equal scroll up. It equals go to, well, let's go back to our bit flags. So we have a bit flag inside scroll dir. So bits, these bits are set for scroll up because this is bit 2 is horizontal. Oh, I'm sorry. We're scrolling left. So this is the scroll bit, right? Bit 3. Bit 2 is a horizontal, and then 0, 1 are the, so, but we also have the go to default bit set, so it doesn't actually equal to scroll up, so it goes to a default setting. This is so if we and with scroll up, then we don't care about the other bits. But the scroll bit isn't necessarily set. So to really detect scroll up, we're going to change all this, but I'm just going to hack it to work now. We need the up left bit plus the, well, just the up left bit. If the horizontal bit is set, then it's horizontal. So we'll and with the up left bit. Oh, that doesn't, wait, hold on a second. I guess first we'll check the horizontal bit, and then we check if it's up left or down right. So here's the scroll up code. It goes ahead and does all this. And then it checks left. And then it checks down. And then it checks right. We want to separate the horizontal and vertical. So, and with horizontal, if it's not equal, we want to branch to So our left and right code. And up left bit branch. If it's clear, then we want to go to right. Called it check right, but we're not actually checking. Anyway. Otherwise it's left. If it was set, then it was left, and under that left code it'll return. Okay, so if we're checking vertical, and branch if equal check down. Otherwise it'll do the up code, and it'll return check down will return. Okay, so I think that works. Garbage characters, scrolling 66. It's the wrong room. It looks like it's always doing room 3, so it always thinks I'm scrolling right. Load scroll dir. Oh, I don't want to do this code. I'm doing more comparisons. All right, looks like it worked. Let's watch it. Yeah, and you can't see it do that jump. Let's try. I wonder if right will just work. Sweet. Okay. Down shouldn't work. Yeah, down just stays where it's at. But we got that working. So This is some progress. Before, every time we scrolled into a room, we had to hit reset on the console and to reset everything to make another scroll. But now we actually handle the default. So this is room. Well, really my first one was bad. It looks similar to this, but it has I think this is supposed to be room. Yeah, this is room 0 here. But this is the room that I load on boot. It looks kind of like it, but room 0 doesn't have the glitches. Anyway, so we can, right now I have it to where if I scroll left, that's room 1. If I scroll right, that's room 3. So I should be able to easily scroll between these two rooms. Left. I can scroll left again into the same room because I hit the left. If I scroll right, boom, right. That's cool. And so now I should be able to, no matter where I am, scroll down. I can't. Scrolling down doesn't. Should we see that on the console here quick? I should have just done it there in the first place. Oh, in the wrong spot. Okay, left, boom. We can go left again. It's just always going to be that room. We can go anytime we hit right. It's going to be this room. Whoops, maybe I hit a button while it was going. But then we can always scroll down. That doesn't go back to default. But this does. That glitching out is just me being impatient. Yeah, and then after scrolling down, it doesn't work because that doesn't reset to default. So that's cool. That wasn't quite as bad as I thought it was gonna be. So a pretty big to do is this set pointer function, but that's going to get into some pretty high level code because was there flicker when I first moved left after moving right, and I think we'll do it again, double check here. I think it's just me being impatient and tapping the button before it's finished. So it's like it's in the middle of redrawing the other screen before we can jump into it, and I tapped it so I don't have any protections against that. Zero move right. Yeah. And I saw that, but yeah, see there you can see if I can trigger it. Yeah. If I initiate a scroll before it's fully jumped back to default, yeah, that's what's happening. Me just being impatient. It looks like it's done, but it's not, right? Because it has to redraw. And I think we can, I didn't watch for that. We can see it here. So I'll hit left, it'll draw this screen, scroll into it, and then it'll draw this screen and flip. But you can, so watch this screen. Yeah. It takes 16 frames to do that. Okay. So what do we want to do now? we so what I want to do, this plan, we've basically like we've got everything wrapped up with horizontal. That's simple enough. Vertical is a pain. Now, I think with horizontal, what we did is we updated the name table, scrolled into it, redrew the default, and then jumped into it. But I think I want to do it the opposite way with vertical scrolls. Instead of, I want to jump around before I scroll. If I jump around before I scroll, I can have it so that I can put the scrolling, so I scroll into the default location, and it makes everything simpler in terms of dealing with the boundaries of the attribute tables. So to try to explain that, so if we're doing an up scroll right now, the initial plan was we just start drawing here on row 3 and scroll up and deal with this edge case. Well, what if instead of dealing with that edge case in the middle of the scroll, we say, okay, up scroll's happening. Draw the current screen in name table 0. Okay, jump over there. Nothing is changed visually. But now name table 1 is clear. We're not using it. We can put whatever we want there. What we can do is draw the current screen in name table 1. But instead of starting row 4, we start at row 0. If we start drawing the top left corner at row 0, then once that's drawn, we can jump back to name table 1, except we have a scroll position up here of 0. And now we're basically, we have the ideal case of an up scroll. We just start updating at the bottom of the attribute table, and we finish in the default position. So that makes up scrolls a lot easier, and we may as well do the same thing with down. For down, which we already have working, but we're not restoring to the default position. So let's think about the down, because maybe down's fine as it is. But for down, right now we just start drawing in the top left corner here, and we scroll into it. But we're down, so the top left corner ends up basically being up here, and we're off by 4 tiles. So we would have to, when we're done with that, it's really not that big of a deal to basically call the same functions that we just did. Draw the current play field in name table 0 starting here. Jump there. Draw, and then we now we're just playing there, and then draw it here and jump there. So I guess for down, it's fine like that. I just don't know if there's it. So if we did it the other way around, so that up and down are basically the same, or similar as possible, we draw the current playfield here, we jump into it, then we could draw the entire, so basically if we do that, then the down case becomes similar to the up. So I think we want to keep it as it is. We don't want to do any scrolling across the edge of the attribute or name tables. So down is already ideal because the first tile that we draw is in the new name table. We did it the other way around. As we're going as we're scrolling down, wait a second. Well, when we did the, what would, okay, this is hard to explain. I'll try, but it makes sense to me. So if we first drew the current play field in nametable 0, flipped over to it, drew the current play field in nametable 1, but in a way that when we finish the scroll, we're in the default position, that would mean that the bottom right corner would be here, and the top left corner would basically be here, which mirrors to here. And so when we made that preemptive draw the current play field in a way that when we finish the downward scroll, it's default, that draw would be difficult. And we want to avoid that. The way to avoid that is the way that we're currently doing it. Yeah. So maybe we can just clean things up and get the down working with the go to default situation here. So let's see here. Put my sweatshirt back on. I'm getting a little chilly. I don't know where it went. Give me a second here. Okay. So when so this is right segment. Okay, here we go. Vertical exit. We stop scrolling and I set the go default bit. And this is good, this method, because remember how we set up the draw the current play field? Between me and Zorch, definitely want to try my hand at NES coding, yeah. Because I think that I might be able to do the scrolling transition thing without as much hassle by using mid-screen raster effect. Yeah. There's some tricks. Part of the it would be interesting to see what you come up with. I play with some different ideas, but when you only have 2 name tables to work with, doing things glitch free can be difficult. And so this is a lot of work, but I saw a clear path for doing it glitch free where I wasn't sure I could. I do a lot. If you go back and look, I forget which stream it is, but I had fairly in-depth conversation on which mirroring I chose and why because of glitching reasons. So I don't know how familiar you are with all that stuff, but you can kind of go back and see, yeah, why I chose this. That's basically it. I knew I could do it glitch-free, or I was pretty sure I could, without any fancy, and the fact that I wanted to try to do it without a scanline counter. Because part of it, and it all changes. If you don't have a heads-up display, there's different ways to attack things. Single screen mirroring is powerful, but it's not. Well, anyway, I'm not going to get into all that, but that's kind of what things come down to. But you definitely should take it up, man. Let's see here. So I set my goal to default bit, and I'm clearing scroll count. Where do I jump if? Yeah, get a dev put to get together. Yeah, a lot of that stuff you really need to test on hardware if you're doing mid scanline raster effects. So so the scroll bit is set, and if it's not, then I want to do, instead of end scroll, I want to jump to check, go to default, which I already have. And so here we're just going to I don't know why I made that a local label, but whatever. So the scroll. I probably know it's already set, but okay. If it's not set, we're going to go to end scroll. 11:30. We're doing better than I was expecting because. Oh, you're saying, yeah, absolutely Unreal hardware. Our former Armagon board workbench with the program, discrete logic removed, flash ROM, and UART. 0.5 MB of RAM. What's an Armagon board? I don't know what that is. That's a lot of RAM too. Curious what you're doing with all that. Or are you just executing, using RAM as your ROM, as being a RAM cart instead of a flash cart, I guess, type of idea. Okay, so here's say my scrolling's done. Well, and I guess we can kind of assume that we're in the down position here, because in the up we're going to set it up so that when we're done scrolling, we're done. So first draw in name table 0. Then draw name table 1. We're gonna have to detect all this. Oh, Armagon is mapper 2 or 3 game. Oh, that's the board, or the game, not the board. Okay, I gotcha. I'm just not familiar with that game. Yeah, host PC download the code and act as a bit of a debugger. Yeah, I want to get my senior design project back to life. It shouldn't be too much. It's just I got a lot going on, but it's a RAM cart with USB. Yeah, UNROM 7. Mapper 2, basically. But my senior design project is just a RAM cartridge with USB, so I could flash it without having to unplug it from my NES. But I didn't really build any debugging thing. Well, I built it in 2012, so 7 years ago now. It used VUSB for AVR microcontrollers. If I were to redesign it, I would use an STM32. Basically just mash my flasher onto a cartridge, which is the same thing I would do now to revive it, because my code is written for both AVR for my old Kazoo flashers and my new ones. So I try to keep it hardware independent. So let's look at so maybe we can still use scroll count. Yeah, so I cleared scroll count. Now we want name table 0. Now, for this jump, we're not just changing the name table. We also need to change the Y scroll, which should be 31 or 32. Depends upon when that update's happening. I think it's... I always forget. What's the default? Yeah, 31. Now the X scroll stays 0, so that... Now we're not completely done. We need to somehow trigger to go back to name table 1. But let's just pretend we're completely done, because this should work. It'll just leave us a name table 0. Well, I'm not going to say it should work, but it might. The plan should work. So left still works. Right still works. All right, let's try down. Okay, something happened there. It doesn't look like it drew it. It jumped over there. Did it draw the wrong room? It didn't draw a room at all. It just jumped. Why didn't it draw it? Did it actually set the go to default or go so store scroll there? Clear scroll count, jump to end scroll. Did I clear the scroll bit? And scroll bit if it's equal. Oh, maybe, let's see. I think I told it 0. Yeah, here I'm saying 0. We can step through the code. Interesting. Let's just step through the code and get a better idea what's going on here. At least frame by frame here. All right, we'll hit down, do a frame, turn it off. Okay. F8. Okay, it's in the final position. Oh, maybe not. Maybe it is. No. Okay, it's in the final position. Yeah, it's drawing it in name table 1 and then jumps over. Why is it doing that? Am I not executing this code, I wonder? Well, I copied it from the horizontal and changed this from 24 to 20. Because I'm trying to draw the current screen on name table 0. Because I was in name table 1. My function's working right. I'm just... I feel like that code's not happening. Let's just set a breakpoint. Because this code, let me just build it again just to... Yeah. So let's see. Check go to deferred. And wait, what? Load scroller and branch angle. Okay, load scroll count. So scroll dir equals 8.2, which sounds right. So then we have a scroll count was 0, branch not equal. LDA 20, store, LDA 48, store, and that should be in memory tools. I think it's 300. So 2048 is where it should be updating. 2048, which is up here, but then it always adds 56. Yeah. Setting the pointer, check vert, scroll down. So it should be loading all that data. Oh, it just changed it. Look at that. Why did it change it? Because it... Let's go look at that. Why did that... Let's look at that code, see if figure out what changed. I wasn't expecting that. Okay, 2048. Setting the pointer. Oh, the attribute table pointer. I forgot about that. But it shouldn't need it. It's going ahead and it's setting it because we needed it for the scroll. Oh, and then here the down scroll is changing the initial PPI. That's why it is. That's why. Here it's gonna mess it up. We can watch it. Boom. There it is. Yeah, I fixed that for I fixed this for the up or for the left right. I cut that code out, but I forgot to do it for down. So we don't want it to do that stuff anymore. For that, so this is for the vertical. Set nat pointer. So we want to, do we know this is up or down? We don't. Well, here's something we can do. I don't like it. Excuse me. Let's... For now, we can just let it continue to do it. If we just let it do it, but correct it after the fact. Not 100% sure what I want, so... Whoops. Well, that's something different. What happened? No, it's F7, not F8. There, it's done. It's... I think the pointer's wrong. Yeah, I know why too, I think. It's kind of correct, but it's off. So set nat pointer for the horizontal, we had it decrement it by 56 because we're on entry, we're always incrementing by 56. But for vertical, we weren't doing that. For vertical, it's by 32. So we should be able to hack that to work. Vert it dex by pre-dec by 32. Draw playfield expects a 56 pre-dec. So we need to decrement the pointer by the difference. Which is what? 24. Okay, 16-bit math. Let's do it right. Oh, here I just, okay, so now this is the nat pointer. LDA nat pointer the least significant byte. I want a normal subtract, which is set, and then uh, 24 STA nat pointer 0. Then I want to subtract with carry. And that's how I do add, but I'm not sure if this is right for not sure I'm doing this right with subtraction. Subtract with carry. So I'm subtracting 24 from the least significant byte. If there was a borrow, I want to subtract 1 from the upper. So actually, I don't need, it's not really 16-bit. It's 16-bit minus 8-bit. So branch if carry clear, because we clear the, or no, we set the carry. We set the carry, then we subtract. If the carry was clear, then there was a borrow. So branch of carry set although I've got a label. Yeah, see this? Whoops. Okay, so there I'm subtracting 24. If the carry is set, we skip it. If the carry clear, then there was a bar out. We need to subtract 1 from the most significant byte. Okay. Vert and it done. All of my code is in one big thing, so my local labels are pretty worthless. May as well be global. I think my breakpoint's on. It's closer. I don't think I... Did it really pre-decrement by 32? Down. I set the nat pointer. I don't pre-decrement it at all for down. I need to subtract 56, not 24. Right. Yeah, I just set the pointer. I pre-decrement the starting address, but not. Sweet. Okay. It did it. So it scrolled down, and when it got there, it jumped over. Just try to double check it here. Okay, so now it's done with the scroll. Now it should start to update the other name table 0. It's still holding the current display. Once it finishes, it jumps. And we didn't see any changes. So now it just needs to jump back to nametable 0. I'm sorry, nametable 1. It's very similar to the horizontal. I kind of want to replicate it, except the current means of the pointer uses the direction, which I don't want it to be. So it's like yet another state, and I'm hacking code because this function is dumb. Part of me doesn't want to hack this code into working for the final switch, because really I need to update that function. Because really this is, whoops. The situation we're in now is identical to the horizontal one, where scrolling's all done. We're displaying in nametable 0. We just need to redraw the current room in nametable 1 and jump over to it. The code I write now is gonna, or the code I would isn't really worth writing. It's 12:15. Let's see. I don't. Thinking about the up code. Excuse me. If the scroll is up, the first thing to do is draw the current room. Name table 0. We can do that. Jump to it. Then we want to redraw the current room. In name table 1, this is like so many draws and so many updates. I like halfway wonder if this is going to be too much, but it's 16 frames per playfield draw. If we have to do it twice, I mean, the game kind of is slow for those scrolls anyway. But that's 32 frames of jumping around, which is half a second. Yeah. But in reality, that we can trigger that drawing early, or do that drawing afterwards, and in these, I don't know, kind of just can't really worry about that part yet. Right now, I just really feel like the code I need is my set nat pointer to be better, be based on a lookup table. Sorry. And although the up is, this is the one case. So aside from that code being better, I can conceptualize everything we need for the down. We're basically already doing it, just for the left and right. For the up, first thing, draw it over here, the current playfield, the first, previous, whatever. Then jump to it, then we draw it here. This is the only time that we're wanting to call the update playfield function and telling it to use, instead of updating on the 4th row, updating on the 0th row. And that affects the attribute table function, or the skip. We will need that, so maybe we can just work on it. Here, if it's up, we got to do a bunch of jogging first, then we can start scrolling. Which is kind of similar to how we had a scroll and a camera bit. My code is similar for up and down, but this is kind of the type of thing I want to throw in a function. So first we need to update nametable 0. Update then nametable 1 top, so that scrolls start at bottom of nametable 1. Finish at default. Down scrolls perform update scroll in nametable 1. Then update jump name table 0, then update jump name table 1 default position. Yeah, and the other thing that's dumb about my setNat pointer function is for up, it's setting the initial address, and it's for up it's setting it to the bottom of the file because I'm working my way up the file, but that's not always how I want to access the data. So I don't think I can intelligibly go any further. Made pretty good progress. Let's to do next stream. Function always points to beginning of data. it's only the special up scroll case that differs, and it can do its own math. Also, PPU start address shouldn't be determined in this function. There's really only a couple. This is really how we want this function to work. We need a lookup table. So the cases when call this function. We lost used we call it and it sets the pointer, but then when the function's done, the pointer's invalid now. Just reset it in this case. Case 2, we room change was some bug on my neck. Triggered need to part of me says to handle some of this, we're better off to have one pointer for current room data. And when we need that, we just copy it over to the NAT pointer. Because the NAT pointer is one that's currently in use, but we can have another pointer that just it's non-volatile, I guess. Not really the right word for it, but it doesn't change. We can restore it at any point. No, maybe instead of storing it, we call this function to have it use lookup table again. I don't know if there's a real big difference between those two things. Could just store call this function so in the case where the room change is triggered and we needed next room's data, we provide the current room and direction of update or change, whatever. Next room. This function needs to use a lookup table to find part of the benefit of, I kind of like the cur room data pointer, next room data pointer, because sometimes the next room, well, we never know which, we want it to mostly be direction independent. And we want this pointer to always point to the beginning. We also may be having some compression going on at some point, most likely. And like for an up scroll, you want, for the first writes, you want the beginning of the pointer because you're going to start drawing it here, then you're going to start drawing it here. And then the last time, you're going to start drawing it from the bottom. So it's a rather lengthy process, and we don't want to have to keep having to call functions to reuse. That's like a one-time thing. We really should only have to do this once. When a room change is triggered, we call this function, and we provide the direction, and it gives the pointers. So nat pointer is the working pointer. It gets ink decremented as being used. Curnat pointer is pointer to current room's data. Next, nat pointer I really needed to explain that out because it's not explanatory at all. Anyway. So I don't know how the lookup table is going to work. I need to think about that. But this just seems like the most sensible way to go about it. I'll think about how to do that, and we'll work on that next stream, I think. So let's go ahead and do our recap. We'll put it on our handy dandy cartridge here. Okay. All right, so this is a recap of stream 17. Last stream we had left, right, and down updates working, and frustrated with getting up scrolls working because of running into the boundary of the name and attribute table. Anytime we jump this boundary, it messes up the data because the attribute table data is always at the end. I know it's hard to explain, but it's a pain. This is simple. So I realized that this could be simplified if, when we did upward scrolls, if we started at the very bottom and we would finish in our default position. And that started to motivate moving some things into some functions, and so that's what we're working on today. It's kind of cheap, but we've got some things cleaned up. So here's a quick look at our scrolling code. It starts off checking if it's horizontal or vertical. If we're horizontal, we're checking the scroll bit, and we set up our pointer to nametable data, and we have this draw play field during v blank. So this function now, it expects the nat pointer to be set, and it expects scroll count to be 0 on first call, and when it's and it also expects that the buffer has the starting PPU address already entered. It currently only supports it to be row 4, but it can be either name table. And when it's done, the Z flag will be clear, which is a decrement of scroll count. So it's the same function. It takes 16 frames to update a play field. It's the same code that we had for horizontal updates, but now it starts to become useful for vertical updates for jumping around. So we did that, and now we were able to start doing our, we never went back to the default position. So now we were able to check for the default bit to be set and draw the play field back in name table 1. So I'll just step through the code here and show you that quick. So for horizontal, first, our default play field is name table 1, and we're going to start drawing the next screen in name table 0. It does 56 tiles per frame. Gets all tiles updated. Now it's going to update the attribute the color data. So now the next room is all loaded up, ready to scroll into. We're going to scroll 4 pixels at a time. Maybe. What happened here? Oh, I forgot to stop holding that. That might have broke everything. Okay. So now it's scrolling into the room. This highlighted area is the current visible screen, just like you see here. So we're scrolling from the vine room into the well room. 4 pixels at a time. We get to the end, and the scroll is done, but if we just stopped here, we were not in a good position for scroll to another room. So this is where I go to default set, and it's going to start updating the default play field back. It's going to start updating with the current room's data. So you should start to see these updates happen. This name table that's off screen is going to start looking like the current one. See the waterfalls coming in, the rocks, the wells, and then it updates the color data, and it just flips the current name table, and you don't see anything on screen, but both name tables look the same, so it just flips it back. And so now we're back in the default position. And so we're prepared to, Zoe is playing that room. We're all prepared to do another room change. We can do the same thing for horizontal, and we're even prepared to do a down room change now. I'm not going to step through it. Well, I suppose I could. So let's do, okay, so I got part of the way there for down. Now down's a little bit different. We're going to start scrolling down, and once we get down, the top left tile is going to be up here, which isn't the right position. So we have to go through name table 0. And I started that. I didn't completely finish it because finishing it was going to turn into a hack. Okay, so here you can see everything like we got working last stream. We're cleanly scrolling into the next room, and we're still going. There, it's done. Okay, it's done scrolling, but you can see the top left tile is up here, and we actually want it to be row 4. In this scroll position, we're not prepared to scroll left. We're basically 4 tiles, a heads-up display worth too high. So to get that down without scrolling, we have to jump through name table 0. So what's going to happen now is this current play field is going to update name table 0. It's off screen. Once it gets done, it jumps over. So the only thing that I haven't finished is the next step is to update name table 1, which is now off screen, and then we can skip back over. It's very similar to the horizontal scroll, but basically it brought me to the point to where my set nat pointer function, it worked. It got us by for our previous development, but it's not versatile at all. It just uses the D-pad direction and then hard coded to room 0, 1, 2, or 3. What we're going to work on next time is these pointers are we use them enough times to where we really just want to set them once, and then we can copy them over. So nat pointer will be the working pointer. We can increment and decrement that as we want, but we want to have a current pointer for the current room. So if we need to redraw it before starting our scroll, and a next nat pointer if we have to draw it several times. And then once the whole scroll update is done, then we can copy it over, and it's over. It's done with nat pointer. I need to figure out how to organize my data in rooms in a lookup table where you can provide the current room and a direction, and that will say, okay, here's the next room's data. So that's kind of where I'm at. And I went ahead and flashed it on the cartridge here so we can see that previous streams I've had, every time I did a scroll, I had to reset the console to be able to do another one. So here's the first screen. We can scroll left, we can scroll right, we can continue to scroll right, and it does the same room because which rooms I'm loading up is based on the D-pad. So the scrolling works for left and right, and I can even do a down from any of these rooms. Oh, maybe not. What happens if you just do a down? So if you just do a down from reset, it works. If we go left and then down, it works. If we go right and down, it works. Well, I don't know why it broke. Let's try it again. Well, part of the problem is I can't get impatient. My code's not blocking me from trying to initiate an additional room change before the current one's done. So that might have been what happened earlier. It takes... Yeah, we got the CRT cam going. I put the... flashed my current build onto one of my boards, and then we can see it on the real screen here. So it looks like it worked. Now I can't scroll from down because I didn't jump back to the name table. If you do, see it's broken. Left or right, I guess, refixes it, but from any of these rooms, we should be able to scroll down. And it does seem to work. I just must not have been patient enough for it to complete. So up still doesn't work. But we're getting closer. I mostly... It wasn't going further down that path. We're getting closer to doing it the right way, but getting it working for the sake of working isn't very worthwhile if it's not done well enough to where we can take the next step with it. So that's what we worked on today, and I'll think about my lookup table and how I want that to work over the next week or so, and hopefully start jumping into that next time. So thanks everyone for tuning in, and we'll see you next week.